Hello. Today I'm going to talk about one of the first steps that have cells turn to the dark side and deform into cancer. When I think of cancer cells, some of them are incredibly metabolically active. Think of creatures like hamsters and mice. Their heart beats in the hundreds per minute. Hummingbirds' hearts beat in the thousands per minute. Can you imagine beating that fast? Some cancer cells are incredibly metabolically active. A normal cell takes in glucose, and the glucose is changed into glycogen when the cell has too much glucose. And when the cell does not have any glucose, the glycogen is broken down back to glucose. This circular feedback loop works very well for cells. However, in cancer cells, they take up glucose again and again, and they churn that into producing other things like nucleic acids, like macromolecules, all getting ready to produce a new cell as the cancer cell divides. Why does the cancer cell have this unidirectional movement of glucose into other macromolecules rather than glycogen? Researchers think that one of the first steps in cancer cells going to the dark side is an increase in the pH inside the cytoplasm. Usually, the cytoplasm of normal cells has a pH around 7, maybe slightly more acidic. However, the pH in cancer cells is alkaline, and it is in the range of 7.5, sometimes 7.7. What the cell feels is this alkaline pH, and so it takes in the glucose to break it down to lactic acid to try and correct the alkaline pH. Unfortunately, the cancer cell is very adept at kicking the H plus out of the cytoplasm. And so you have this perpetual cycle of glucose trying to produce lactic acid and the acid being kicked out of the cell. All these extra byproducts of glucose breakdown have to go somewhere, and they're channeled into production of other macromolecules and nucleic acids, which tell the nucleus it's now time to divide into another cell. Researchers have shown this again and again. One of the first steps in the transformation of cells into a cancer pathology is an increase in the number of proteins which kick protons out of the cancer cell. And this is followed by the pH rising in the cytoplasm, which is followed by increasing glucose breakdown in the cytoplasm. Interestingly, hypoxia, chronic hypoxia, also produces the same thing because when the cell is hypoxic, there's increased acid in the cytoplasm. So the cell revs up to remove this acid, and this creates a perpetual cycle of the cell trying to remove the acid, but because it's always hypoxic, it's always trying to remove all the acid from the cytoplasm. Cancer cells produce a tumor mass, which tends to be hypoxic and tends to have a lot of acid outside the cells. There you have it. You have a dysfunctional inside of the cell, which has already produced an alkaline cytoplasm, and you have a dysfunctional outside of the cell, which has too much acid and too little oxygen. Those together create the perpetual cycle of the cancerous cell not dying, but continually dividing again and again as it tells the nucleus, well, you have all these macromolecules, why don't you do something with them? In this way, we see that one of the earliest signs in cancer pathology is an increase in the pH of the cytoplasm.